Hey guys, and welcome back to a new video. Today I'm going to show you how you can properly validate your forms using clean architectural guidelines. So we will use use cases here to do that because that's business logic. I will show you how you can use a view model in this context and how you can send all these validation events to the UI and from the UI to the view model, because that's something you need in pretty much any app that deals somehow with data. So we will build a very simple registration form here where we can enter an email, a password, we need to repeat it, and we need to accept some terms and conditions, and then we can click on submit. So if we just click submit here, you will see we will get a bunch of errors. That's what I will show you here. Email can't be empty, of course. Let's change that to something that's not empty. We click submit. It tells us that's not a valid email. That's true. So let's enter a valid email. If we then click submit again, that error will go away. However, we still need to fix the other ones. Like let's choose 1, 2, 3, 4, 5, 6, 7, 8 for the password, because it needs to be at least 8 characters long. We click submit. Then it tells us, okay, the password actually needs to contain at least a digit and a letter. We just enter digits. So let's add an H or so. And we of course need to repeat the password here. So 1, 2, 3, 4, 5, 6, 7, 8 and an H. We then click submit and it still tells us, please accept the terms and conditions. We do this, click submit, and then we get our toast registration successful, where you would just navigate to a different screen or so, or do whatever you like when it should be, when it is successful. Jumping into an empty compose project in Android Studio, let's actually start by creating our view model. First of all, I added this dependency here, view model compose. Make sure to add the same one, because otherwise you don't have access to view models in Compose. Other than that, this is a fully empty project. You can just create in Android Studio. Let's go to our main package, new Kotlin class, and I will call it main view model. And that should of course be scoped to the specific screen you have here. Since we only have one screen, I will scope it here directly to the main activity. Let's select class and make that inherit from a view model, just as usual. Okay, so what do we now want to do here as a first step? What I like to do is I like to create a wrapper class for our actual screen state, for the UI state that we want to show. So everything, every single value that can change over time, like the values of the text fields, like the single error messages or so, those belong in the state. So I will actually go here to my root package. And because, as I said, we want to stick to clean architectural guidelines, that means we divide each feature in presentation, domain, and data layers. Well, what do we deal with here for validation? We, of course, on the one hand deal with presentation, so what's visible in the UI. So we deal with our text fields, with our view models, which is also presentation. But on the other hand, we also deal with the domain layer, which contains our actual business rules and business logic, which in the end is, for example, validating some stuff. And for that stuff, for validating an email, for validating a password, for each of these, we will create a use case. What that exactly is, if you don't know that, I will get to it when we create that. Let's actually start by simply creating a new package here in our root package called presentation. Let's move in our main activity and main view model in there, click refactor, and then go to our root package again, create another package called domain.usecases, or just use case as you like. And that's where our use cases will be located. We don't deal with any data related stuff here, so we don't need a data layer. Usually you have that, of course, but here we don't. So let's start in our presentation layer, where we want to create a new Kotlin class called validation state, or let's say registration form state, because that's what it really describes. So we select data class, and in here we need to think about the different things that can change on our screen. Like, for example, the value of the email the user entered, but also something like the email error message, which is a nullable string here. So if that's null, we just assume, okay, there is no error, and else it's just the error message. And by the way, the email is empty by default. Then we have the same for the password, which is a string, empty by default. We have that for the repeated password, which is a nullable one again. We have that, actually we need to have a password error here as well. Password error, nullable string. And actually the repeated password is not nullable. That's of course just the value we entered for the repeated password text field. And then we have a repeated password error, which is a nullable string, as I said. And we have a Boolean actually, whether we accepted the terms or not. And that's of course false by default, so the checkbox remains unchecked. And since we also want to show if the user did not accept the terms, we also want to have an accepted, or let's just call it terms error, which is a nullable string again. So we just initialize these values here with their default values, how it should look like on a very empty screen, you can say. So when the user opens that screen, then this is the state that should reflect how it will look like at that specific time. Back in main view model, let's create our state here, because the job of the main view model, especially in clean architecture, is to make use of use cases. So the use cases will contain the business logic, like the validation logic here. For example, whether the password is longer than 8 characters or not, whether the email is a valid email. That belongs in the use cases. And the view model will then make use of these use cases and map the results to compose state. So it will call the validate email use case when it checks, okay, was that validation actually successful? If yes, then I will change the state we have here correspondingly so that it is correctly displayed in the UI with that error message, or that the error message is hidden if there is no error. Stuff like that is a job of the view model. So we can make use of the delegate here, var state by mutable state of, and we import this here twice actually, pressing Alt plus Enter, and we initialize an empty registration form state. Cool. Then the next step is, let's actually create our use cases. We could do different things here. We could also set up our UI or so. There is no real fixed order we need to follow, but let's start, or let's continue by going into our use case package and start by creating a class called validate email. Press Enter here. So, and let's now talk a little bit about what a use case actually is and what's the purpose behind that. So use case is a very integral part of clean architecture, and it's kind of a middle layer between your view model and your data layer. So the use cases would then maybe access a repository that accesses your database, or they would directly access some kind of data source. And the reason why we have these use cases in clean architecture is that they are actually an excellent way to follow the single responsibility principle. So that's the S of the solid principles, which just states that each class, each function should really just do one thing, should really just have one responsibility, or some people say one reason to change. So if we have a class and it could happen that we change this because our email validation logic changes or because our password validation logic changes, then that class doesn't have a real responsibility because there are two different reasons it could change. And we want to solve this problem by making use cases. So by having a class for really every single bit of business logic we have in our project. So typically each use case consists of just one function which executes that use case. So which validates the email in this case. Let's write that function, execute, and open the body here. Some people like to make this an operator function to override the invoke operator, which I also often did in my previous videos. But just to show you a different way, you can also just call this execute. It really doesn't matter. You just need to make it obvious that this executes the use case. Okay. So this function should now validate the email. On the one hand, we, for example, want to check whether an email is blank, is empty. So what we can do is, if actually the email we pass here, the email we want to validate, if that's blank, we somehow want to tell the client who executes our use case hey, that email is actually blank. Here's the error message. Please show that in the UI. And the client would be the view model here in this case. So how do we do that? And the reason, the way I will fix this, or the way I will solve this, is by creating a result class. So we will simply return a result class here that will tell our view model whether this validation was successful or if there was an error. And if so, which error there was. And since this type of validation result will be the same for all of our different use cases, let's go to use case and make that a class here. If this type of result class would really differ per use case, then what I would do is I would create that as a child class here, as a subclass inside of the validate email use case. So data class result, and then have all your fields that are individual to the email validation here. But since it's the same for all of our use cases, let's go to our use case package and create our validation result. Make it a data class. And on the one hand, we want to check whether that validation was successful or not. And if it was not successful, what is actually the error message? And that's a nullable string. And that's already it. So we can jump back to validate email, return such a validation result. And if that email was blank, we return a validation result. In this case, it was of course not successful. And we want to pass an error message that says, okay, the email can't be blank. And that's how we really tell the view model then what error happened. Of course, in a real project, I would use string resources. If you want to learn how you can use string resources in a use case without actually needing the context, then I will link a video up here where I will show you exactly that. But for time reasons, I won't do that here in this video. So, next step, what else do we want to validate? Well, the user could have entered an email that's actually not a valid email, but that's also not blank. So we also wanted to check that. And there is a very nice way to check that, which is patterns from Android util, email address matcher. We pass our email and we check whether that matches. And if that does not match, we know that's not a valid email. And in a true clean architecture project, you would probably abstract this out somehow so you don't have these Android specific implementation details in a use case. But that would really be too much here for this simple tutorial. So you would kind of wrap that into an interface like an email matcher or so. And then you have an implementation of that which uses this patterns, email address, blah, blah, blah. But here, let's not do that. And the error message would be, that's not a valid email. And of course, you can add a lot more validation here as you like. I will leave it at that and just return a successful validation result in this case. And we don't need to pass an error message. And that's our very first use case to validate an email. So it's a very, very readable way. So we just see, okay, if it's blank, it fails. If the pattern doesn't match, it failed, and else it's successful, and you can easily extend this. You can super easily test this function, and this class now only has a single reason to change, and that is that our email validation changes. Okay, let's jump to the next use case, and that is to validate a password. For that, I will simply go to my email use case, copy paste it, copy paste it, yes, and we call it validate password. So this time the parameter changes to password, of course. It will still return a validation result. And here I will just check whether the password.length is less than 8. Super simple. In a real project, I would make that 8 a constant, so you can change it easier. Here we will say the password needs to consist of at least 8 characters. Like that. What else can go wrong? Well, with the password, of course, it could be that we want to check if they're like at least a digit, at least a letter or so. So we could say val contains letters and digits. And we could check that, for example, using the any function, which goes through all the characters and checks whether this condition that we pass here is true for any, so for at least one character. So at least one character should be a digit. Actually, it is digit. And password that any, and one character, of course, needs to be, at least one character needs to be a letter. And if that is not the case, so if it does not contain letters and digits, so it might only contain digits or only letters, we want to return that result. The password needs to contain at least one letter and digit. And else we again return the successful result. Next up, we're going to go to validate password, copy paste, and we want to call it validate repeated password. So really for every single step, we have our own validation use case. This time we also want to pass the actual password and the repeated one, since we need to compare these, of course, and check whether these are the same or not. So if the password is not equal to the repeated password, that was not successful, and we say the passwords don't match. And that's really everything we want to check here for the repeated one. Can remove the import and do one final use case, which is to validate the terms and conditions, which is super simple here because we just want to check whether the Boolean is true. But if you truly want to follow clean architecture, that's business logic. If you have that if statement and you want to put that in a use case, because imagine sometime in future you decide, okay, maybe the user does not need to accept the terms in a specific case or so. And then you just need to change that logic in the use case and not in all classes that use the use case. So let's go here, copy paste, validate terms. Here we can pass like whether the terms were accepted or not. And remove that stuff here. We just want to check if the terms were not accepted. We say, please accept the terms, and else we return true. Cool, now we have all of our use cases. And the way we use these in the view model is we inject them in the constructor. And when I say inject, I usually mean by using something like Dagger Hill, the dependency injection framework. But since that would make this here too complex, I will simply instantiate these here all in the constructor, because these classes don't need any parameters. Don't take this as a best practice. Usually you want to use dependency injection. So let's say validate email is a new validate email instance. Private val validate password. And yeah, private val validate repeated password. Private val validate terms. Like that. And now our view model can easily validate the fields with these use cases. And even if there are other screens which also might need to validate an email, maybe the login screen, then they can just use that use case again, and you don't have that duplicate code, the duplicate validation logic. And that's what really makes use cases cool and helps your projects to really scale. On the other side, usually for smaller projects, they are way too overkill. I recently made a video here about why I think best practices can sometimes be dangerous. So in case you're interested in that, why I think that, you can also, it's not too long ago, you will find it on my channel. But there I talk about, yeah, why use cases, for example, sometimes are way too overkill. But here I just want to show you how you would do it in a really big project. Cool. What's the next step? The next step is that our view model actually makes use of these use cases and properly maps the results to our state. And for that, I like to create a seal class, an event seal class, where each event corresponds to a single thing the user can do on the screen. So a single thing could be entering something in the email field, it could be entering something in the password field, it could be checking the terms checkbox, it could be clicking the submit button. All that things that kind of involve user interaction. So in the presentation package, I will create a new class, and we call that registration form event. Make it a sealed class, and in here we specify these events. On the one hand, email changed, passing to the new email, like this. We can then duplicate that some more times. We have password changed, passing the password, repeated password changed. Let's put that on a new line. Repeated password. And we have accept terms. Val is accepted. Cool. And we actually have one more. And that's an object. Just submit. So when we click the submit button, because that of course doesn't need any parameters since we just click on a button. So back in main view model, we will now have a function on event which will receive such events from our actual screen. And here we can very easily distinguish between these different events. So on the one hand, we could have an email changed event. We could have a password changed event. We could have a repeated password changed event. We could have an accept terms event. Or we could have a submit event. And in these four cases, it's very easy because we just want to map our state. If we entered an email, we know we want to simply set the state to state.copy, and we just want to change the email to whatever we got from the event. And sometimes I get the question why we use this copy. That's just making an independent copy of the state. So we can't directly change the fields of our state. So we can't say state email is event email, because email is a val and it also should be a val. So you should always rely on immutable fields. So the way to change the state is we need to change the whole state object. So we create a copy of this, and all we do is we change the email of that copy. And here, for the password case, we change the password of that copy. And here we change the repeated password. And here we say accepted terms is event is accepted. What's that? Did I make that a string? Yes, I did. Of course, that's a Boolean. Okay, and then we have one last case left. That's submit, which is a little bit more complex because we of course need to make use of all of our use cases. So let's call that submit data, a function I will create. We can press Alt Enter and say create function submit data. And here, let's just get our different results by using our use cases. So email result is email, a validated email, execute, passing our state email. We have password result, validate password, execute, passing state password, repeated password result is equal to validate repeated password, execute. Here we need to pass both the password and the repeated one. And we have the terms result, which is validate terms, execute, state, accepted terms. Cool. And now we want to check whether there is actually an error or if that was successful. So has error is, I'll create a list here, passing all these different results. So password result, repeated password result, and terms result. And if any of these results actually has an error message that's not null, so if any has an error, then we know there is an error for at least one field. We could probably also check if any is not successful. That's probably a little bit more readable. Then we want to check that. If we have an error, we want to map our state again. This time we say email error is email result.error. Password error is password result error message. Repeated password result error message. And terms error is terms result.error message. And after that, we want to return. And here, if we don't have an error, we want to launch a coroutine actually in ViewModel scope, because now it's actually the other way around. Till now, we only send events from our UI to our ViewModel here. Now we want to send an event from the ViewModel to the UI, because we somehow need to tell the UI, hey, now the validation was actually successful. So what we will do is we will create a channel, private val, and that will be, what do we call it? Validation event channel, let's say. So the purpose of a channel is to do exactly that, what I just described. It is to send events into this channel, and the UI can then collect these changes by simply collecting from a flow. I like to also create a CL class for this. Here in this specific case, we only have successful events. I will still show you to do it like how you would do it in a really big project or in a normal project, which is called validation event. We don't have that. No, we don't. And here we have a success event. Like that. So now we can have that channel of type validation events. And since we don't want to expose this channel to the UI, since we don't want the UI to send something into this, we want to expose an immutable flow. So val validation events is validation event channel receive as flow. You will sometimes see people do this with a shared flow. A shared flow should be used if there are multiple observers, so multiple screens observing the same flow. Here we only have one observer, which is our screen. Then you should use a channel. Then going down here, this is now executed if the validation is successful. So we can say validation event channel send, and we want to send a success event. That's now everything for our ViewModel. And the next and last step is to implement our UI to send these events to this ViewModel here, and then we can already try it out. So let's go to MainActivity. In the surface, I'll create a column, which I will assign a modifier of fill max size. Give it a little bit of padding, like 32 dp, and import dp. We want to say, okay, the vertical arrangement is center, so we center all of our stuff. Horizontal arrangement will not be so necessary because we just make all the stuff fill the whole width. So let's actually start by getting an instance of our ViewModel. I will do that here. So val ViewModel is a ViewModel. We use this composable function, and that will be an instance of main ViewModel. Then we want to have a variable here of our state. ViewModel.state. And I want to have a context because I want to show a toast when we actually successfully validate our fields. Local context.current. Let's actually start with that successful case. So how do we now observe this event channel I talked about? We will use a launched effect block. And for the key, we pass a context, which just makes sure that as soon as the context changes, this launched effect block will be relaunched, kind of, which I think is never the case, but I like this more than just passing true for the key, which would never execute this launched effect block again. So let's go here and have our ViewModel, validation events, and we want to collect these. So this will now be fired every time we send something into this channel, which in this case is only the case when we successfully validate the fields. So we can now check when that event is actually a success event. we want to show toast. Toast, make text. Passing the context, passing a text, registration successful, and passing a length. And saying that show. Just like that. That's already how we can listen to these events we send here into this channel. So every time we call send, then in the UI, this collect block will be called with that corresponding event we send into this. So in here in this column, we want to have some text fields. I'll just choose the material ones here, putting this on a separate line. And the value of this one is, of course, email. When we change this email text field, we want to now use our review model on event, and we send the email changed event, passing the new email, so it. And what else do we want? Well, we want to have an is error. So whether the text field should should be shown in red, whether there is an error or not, which is state dot email error is not equal to null. Then we know there is an error. Then what else? We want to have a modifier fill max width. We want to have a placeholder, which will be a text composable that just says email. We want to have a keyboard type, keyboard options actually, keyboard options, and here we can pass a keyboard type, which for this one is keyboard type email. So it just shows the most helpful fields on the keyboard for entering an email. And is there something else we would like to pass here? I don't think so. So we can simply keep it like that. And below this, we want to have a text, actually only if the state email error is not equal to null. So if there is an error, we want to display an error text. And this text will be equal to the state email error. And the color of that will be in our error color. Material theme colors error. Oops. And then we can simply put a spacer below that, passing a height of 16 dp. And now we can just do a bunch of copy pasting. I'll copy this whole stuff. Do it for the password field. So state.password. We send the password changed event. The error is when we have a password error being not equal to null. Placeholder will be password. Keyboard type will be password. And here actually one thing changes, and that is you want to add a visual transformation of a password visual transformation. That just makes sure that you see these password dots and not the clear text password, which is of course something you usually want with password text fields. The error message for the password should show if the state password error is not equal to null. And here as well, password error. Rest is fine. Let's copy this stuff again. Pasting it down below for the repeated password. So text field, repeated password. Repeated password changed, repeated password error. Repeat password. That's fine for the keyboard type. That's also fine. Repeated password error. Repeated password error. And now for the terms, we can simply paste the text field. We want to instead have a row. Yeah, it'll just fill the whole width. So fill max width. And the row will consist of a checkbox. The checkbox is checked if a state accepted terms is true. And when that changes, when we tap on the checkbox, we want to save view model. On event, accept terms. And we pass it. So whether we accepted it or not. I think that's it. After that, we would like to have a little bit of horizontal spacing. Let's say 8 dp. And then we have a text that just describes accept terms. It's like usually you would use something like accept terms and conditions or so, or yes, I have read the terms and conditions. I'll just keep it simple here. And below that, we again have an if condition. if the state terms error is not equal to null, we want to display another error text where the text is equal to state terms error, and else, not else, the color I mean is the error color. And then the only thing that's missing below this terms error is our actual submit button. And here on click, when we click that, we send the submit event to the view model. I want to make sure that's actually aligned to the end, alignment.end. And the content of that button is a simple text where we say, okay, submit, or register, whatever you like. And when I think about it, we should also add these alignment modifiers to our single error texts, I guess. Yes, let's do that. Actually, not for the terms one, but for the other ones. Here, repeated password error, and here, the email error, so that they just stick to the end of the column. I think that should be it. Let's try that out. And let's first of all click on submit. Then all these fields give us errors, except for the repeated password one, because these passwords actually match. Like empty is equal to empty. But let's enter something, an invalid email, like a password that consists only of numbers. Let's also repeat that. And now let's accept the terms. I can see that's not a valid email. Password needs to contain at least one letter and digit. Please accept the terms. Let's check that. That error goes away. Let's add a letter here. That goes away, and we enter a valid email. Then registration successful. So it seems to work just fine. And now, thanks to making these single use case, these single validation functions use cases, we can super easily test these. Let me just write a very simple sample test case. We just go here to valid email, Alt enter, create test, select JUnit4, have a setup function, click OK. That's a unit test. Doesn't need any. Oh, it actually does. So that's one thing, one reason why I would write an abstraction here actually for this patterns email address, because you see that comes from Android, and if you want to test this, you now need an instrumented test, which is slower. So that's actually one good reason why you should write an abstraction for this in a clean architecture project. Let's do this for the validate password use case instead. Then here we remove the import, create test, setup, click OK, select the test source set. And here we can then just have our instance or test instance, validate init variable, validate password, for example, is a validate password use case. And in setup, we initialize that. Of course, that's not a course about testing now, where I won't go into detail, but I'll just show you how easy that now is. That's a new validate password use case. You should just make sure that you use brand new objects for every single test case. So that's called before every single test case in this class. And then we could have a test case here. No Siri, I don't want to test you. We instead say function. Oops. We can say, okay, what could we test here? Take a look at the use case. I want to test if this is actually, if the password, well, let's say we enter a password that's only consists of letters, and we actually get an error. So password is letter only, returns error. That's what we expect. So we can say, okay, val result is validate password.execute. I want to test this with A, B, C, D, E, F, G, H, which I think is 8 characters, so that's fine. And then we want to say, okay, we assert that result successful is actually false. I think with JUnit we say assert equals, and never use this assertion framework. So we want to assert whether the result successful is false. And if we now run this test case, we see instantiating tests, and then you can see it passes. If we now go to validate password and we change this here, for example, someone actually messes this up and removes this is letter block. We rerun our test, then it should actually, it still passes. Yeah, of course, because I removed the wrong block. So right now it would check, okay, whether it does not contain digits, then it's an error. So if we remove this instead and rerun the test, then okay, it actually catches the error. It expected to be true, but it was false. So yeah, working unit test just has a very quick demonstration how you can now do that with the simple use cases. I hope that was helpful, and I will link the relevant videos here regarding best practices. You can just click here if you want to learn why best practices such as use cases can sometimes be dangerous. And other than that, I wish you an amazing day and an amazing week, and I hope I see you back in the next video again. Bye bye.